What if you didn't use the readings on your UT set? What if you just used the lines? First off, thanks to my friend Max Yates from Sonaspection for the cool shirt. You know Sonaspection, they make flaw specimens. Max is actually a world-class professional drummer. He's toured all over the place. He's part of this band now called Takeaway Thieves. I will put a link in the description. I am so used to doing everything with phased array that every time I go back to conventional UT, it takes me a little bit to get my bearings. On conventional, we see the response with just one angle, but nowadays, because it's 2020 something, we have UT sets with fancy gates, different gate modes, display colors, peak mem, and even a scan plan view on the Sonatest Wave, all of which makes everything much easier than it used to be. But let's say you want to make things hard on yourself, like maybe they were 40 years ago. Apart from just being stubborn, there's a good reason to get good at looking at things the hard way. For this example, I'll use my Sonatest Wave and this flaw bar from Flawtech. Now, these are just sections of weld with one flaw in them each, much easier for training than hauling around a 10-pound plate each and every time. And for the transducer, I'm going to use this really small 10 megahertz Sonatest 45 degree. We're going to do the whole thing with just the A scan, so I'm going to maximize my screen and crop the top of it out with my video software and do this old school, no looking at the numbers. You've probably heard about setting the range to show 2.5 legs. And the reason is on a 10 division screen, the first leg goes from 0 to 4, so that's the back wall there. The second leg off the bounce is the section here, back to the entry position at 0.8, and then another half leg for divisions 9 and 10. By doing it this way, you've divided the weld into quarters. You look at the A scan first before you look at the numbers. Not unlike driving a manual transmission, you do the thinking. Don't let the machine do the thinking for you. The flaw bar is a 1/4 inch thick. It's got a toe crack up here on the top, and at 45 degrees, the distance back for each leg is the same as the thickness because that's how triangles work at 45 degrees. So I have to move 2 times the thickness, or 1/4 inch times 2 equals a 1/2 inch back from the weld toe. But let's be clear, you don't always get a nice corner trap signal, especially if the crack is skewed, but in this case, it works out really well. The depth of a flaw should always be measured to the deepest part. So on a top surface crack, the depth is measured from the surface to the lowest crack tip. To get the crack tip, once you find the corner trap, you have to move the probe towards the weld in order to pick that up before the end of the second leg. If you want the reflection off the third leg, you'll have to move the probe further back. We peak up the corner trap, then push the probe forward. Watch this one peak right here. That's the tip on the second leg, then maximize so it's right in the middle of a 45 degree beam. It's at about 25% of the way down, or 1 screen division. A 1/4 inch times 25% is a 1/16 of an inch, or about 60 thou. Pretty simple, right? Because we've used 2.5 legs, each one of those lines is 25% of the thickness. Now, I really think that phased array should be introduced right at the beginning of UT training because I think it makes everything so much easier. So I'm going to fire up the Veo and a 10 megahertz Vermon NDT 32 element type 10 probe, and I'm going to focus right at the sweet spot. Here's the corner, there's the tip signals on the second and third legs. Throw a cursor on the screen and it's at 60 thou, which is exactly what the master sheet says. Sizing tip diffractions using conventional and phased array give us the same answer. So let's take this opportunity to pick on dB drop, shall we? If dB drop worked, then I should be able to, say, use a 5 meg 60 degree. Should give me the right answer, right? Not even close. Learning how to recognize and size cracks properly using an A-scan takes a bit of practice, so it's really important that you set your screen up right and you keep your eyes on the waveform and not necessarily on the numbers at the top of the screen. I hope you enjoyed this video. If you did, please hit the like and subscribe buttons, and thanks for watching.